Hello, I'm Saladin HI. Today we are going to look at electric current. Our learning objectives for today. At the end of the lesson, you will be able to define electricity, define energy and potential difference in circuits, explain why a series or parallel circuit is more appropriate for particular applications, including domestic lighting. Understand that the current in a series circuit depends on the applied voltage and the number and nature of other components. Understand that current is the rate of flow of charge. Know and use the relationship charge equals to current times time, that is, Q equals to I times T. Know that electric current in solid metallic conductors is the flow of negatively charged electrons. Electrical conductors and insulators. An electrical conductor is a material through which electric current flows easily. All metals are conductors. Electrical insulators have a very high resistance to the flow of current. Let us complete the table below. For copper, it is a conductor. Rubber is an insulator. Steel is a conductor. Mercury is a conductor. Paper is an insulator. Plastic is an insulator. Diamond is an insulator. And we have graphite, it's a conductor. Electric charge. Electric charge can be either positive or negative. In an atom, an electron has a negative charge that is of the same size as the positive charge of a proton. Neutrons have no electric charge. You can see the diagram on the video. An atom has the same number of electrons as protons. It is uncharged. Electric current. An electric current is the rate of flow of electric charge. An electric current of 1 ampere flows when a charge of 1 coulomb C passes a point in an electric circuit in 1 second. A metallic conductor is, for example, copper wire. Electrons carry negative charge from the negative side of a power supply around the circuit and back into the positive side. Here we have the diagram of a bulb connected to a battery. The arrow there shows the direction of the electron as it flows. Charge current equation. The formula for electric charge is current times time, which is Q equals to I times T. Also, we can say that for current, Q is divided by T, while for time, Q is divided by I. Now, this is a way of getting the formula here by drawing a triangle. Here we have a triangle. At the uppermost we have Q, down it we have I, and also we have T. Now, in order for us to get the current, we can say here, for us to get the current, let us cancel this. It means what we have here will be what? Q divided by T, meaning the one we cancelled will now be equals to what remains, that is Q divided by time. So we have it like this. So if you want to find the time too, you can say what this is. This is going to be cancelled, that is, we are looking for the time. Which equals to the remaining part is what? Charge and current. These are the remaining parts. So we have what? Q divided by I. So this is a simple way of finding the formula. Now let's look at this question. Calculate the charge passing through a device when a current of 500 milliamperes flows for 3 minutes. Now to find it, that is the solution. We have our current to be 500 milliamperes, which equals to 0.5 amperes. Then T equals to 3 minutes. Our Q is unknown. So we can now say Q equals to I times T. Here we have 500 milliamperes times 3 minutes. So our 500 milliamperes will give us 0.5 ampere, while our 3 minutes will give us 180 seconds. What we have done here is that we said 3 times 60, because 60 seconds will give us 1 minute. That's how we got our 180 seconds. So we can now say the charge is 90 coulombs. Now, another question, we have calculate the current flow when a charge of 240 coulombs flows through a device in 80 seconds. Here we have the solution. Our Q, that is the charge, is 240 coulombs. T is 80 seconds and our I is unknown, that is the current. So we now use the formula current equals to Q divided by T. Our current now equals to 240 coulomb divided by 80 seconds. And the final answer is 3 amperes. Now, let us complete this table. I'm waiting for you. Now let's do it together. No. The answers: 30 seconds. For the third table we have 65 coulombs. Then here there is a typographical error here. The final answer you should get here is 4 amperes. So let me write that 4 amperes. So if you are unable to get 4 amperes, please do your work. And here you should be able to get 60 seconds. Voltage. A battery gives electrical charge energy. The voltage of a battery is equal to the energy in joules provided when a charge of 1 coulomb passes through the battery. Voltage equals to energy divided by charge. 1 volt is the same as 1 joule per coulomb. Question. Calculate the voltage of a battery if it supplies 300 joules of energy to 50 coulombs of charge. The solution: energy equals to 300 joules while the charge is 50 coulombs. And the formula is voltage equals to energy divided by charge. Here we have 300 joules divided by 50 coulombs, and the final answer is 6 volts, which means what 6 volts is the battery voltage. Let's complete this table. Let me wait for you. To do that, you know the right formula to use. I'm waiting. Now let's do it together. Now here you should be able to get 40 coulombs. Here you should be able to get 20 volts. Here you should be able to get 120 joules, and here you should be able to get 300 coulombs. Now choose appropriate words to fill in the gaps below. So I will give you time to do that also. These are the words you have to choose from. Now let's do it together. Electric current is the rate of flow of electric charge. So charge should be there. Electric charge is measured in coulombs, so coulombs will be there. A battery provides electrical energy. Energy is the right word there. The amount of energy provided per coulomb of electric charge passing is equal to the voltage of the battery. The main supply gives 230 joules to every coulomb of charge. So you can check what you have written down. Now electric circuit. An electric circuit will only flow if there is a complete unbroken electric circuit that contains a power supply. A circuit diagram uses a standard set of symbols to show how electrical components are connected together. Electric circuit symbols. This is the symbol for cell. The cell is required to push electrons around the circuit. This is the symbol for battery. A battery consists of 2 or more cells. This is the symbol for wire. Wires should always be drawn as straight lines. This is the symbol for wire junction. A point connecting 2 or more wires together. This is the symbol for switch. A switch enables the current in a circuit to be turned on or off. This is the symbol for indicator. Often a light bulb. This is used to show whether or not a circuit is on. This is the symbol for light bulb. Both symbol, that is the indicator symbol, is now used. This is the symbol for ammeter, which measures the electric current in amperes. This is the symbol for voltmeter, which measures voltages in volts. This is the symbol for fixed resistor. A resistor is used to limit the current in a circuit. This is the symbol for variable resistor, a resistor of which the electric current value can be adjusted. Thermistor, a device whose resistor decreases with temperature. This is the symbol for light-dependent resistor, LDR, a device whose resistance decreases with brightness. This is the symbol for diode. The diode only allows electric current to flow in one direction, which is shown by the direction of the arrow there. Light emitting diode, LED, a diode that emits light when it allows the flow of electric current. Symbol for fuse. A fuse is designed to melt and so break an electric current when too much electric current flows. This is the symbol for heater, a device used to convert electrical energy to heat. Electric current flow. Electric current flows from the positive terminal of a power supply around the circuit to the negative terminal. Here we have the diagram. The longitudinal line of the symbol for a cell is the positive terminal. That is, we are talking about this thinner line, and it's longer than this. In the circuit above, the diode is aligned so that it allows current to flow through the radio. Electric current flow. Let's watch this video.
Here is an initial arm. The wire has been connected to the terminals of the battery, and here we can see that the circuit diagram is well drawn here. The arrow represents current, the E is the voltage for the battery, the R is the resistance of the resistor, while the A is the lamp. The I has been indicated shows the current flowing through the wire. So this is the circuit diagram as it's drawn from the circuit you are simply connected to the lamp.
Now, Ohm's law. Ohm's law states at constant temperature and other physical factors, the potential difference across the end is directly proportional to the current passing through a conductor wire. Now, this is the graph of current against voltage, which shows Ohm's law, and we can see that the slope is what? 1 divided by R. Now, from Ohm's law, the potential difference is directly proportional to the current, which is equals to what? IR. When you remove the sign of the proportionality there, it becomes IR. And the I there stands for the current, which is what? A constant. Now, the graphical representation of Ohm's law, the graph of voltage against current, which we have talked about. Potential difference, PT. Potential difference between any point in a circuit is the work done when one coulomb of charge moves from one end of the circuit to the other, that is, from the positive to the negative pole. Unit of PD, that is the potential difference, is volts, represented by letter V. A cell gives an electrical force or pressure across its terminals, known as the electromotive force, EMF. The EMF of a cell in volt is the PD between the terminals of the cell when it is not delivering any current to this circuit. Other large and small units of PD are kilovolts, kV, and millivolts, MV. 1 kilovolt equals to 10 raised to power 3 volts. It's supposed to be 10 raised to power 3 volts. So don't mind my typographical error there. Then 1 millivolts will give us 10. This will be 10 raised to power minus 3 volts. The instrument for measuring PD is known as a voltmeter. Now let us complete this. So now, let us look at the symbol and component. Now, So this is the complete table. So try and check if you have gotten the answers right or not. Now, question: draw a circuit diagram for the torch shown below. Let me give you some minutes to draw it. So this is how it looks like. Series circuits. Circuit components are said to be connected in series if the same electric current passes through each of them in turn. Here we have the circuit diagram. Here we have 3 amperes flowing, that is 3 amperes of current is flowing, and it enters the negative terminal. And of course, you know that this longer, thinner line is the positive, while this other one, the shorter one, is the negative. Now the cell and the 2 lamps are in series with each other, and so the same electric current passes through all of them. In a series circuit, all of the components can be controlled by using just one switch. Here you can see the switch is closed, and here again is opened, closed, and the lamps are on. Each component shares the voltage of the power supply, and so adding more bulbs in series will cause each bulb to become dimmer. You can see they become more, here becomes brighter, dimmer. Parallel circuits. The voltage across each component connected in parallel is the same. This is the circuit showing the parallel circuit. The voltmeter reading for component X, V1, will be the same as the voltmeter reading for component Y, V2. In a parallel circuit, all of the components can be individually controlled by using separate switches. So this switch will on this lamp, this switch will on this lamp, this switch will on this lamp. Now, if one light bulb blows, the other bulbs will still carry on working. Current in parallel circuits. The total current through the whole circuit is the sum of the current through the separate components. Here we have a circuit diagram. Here 5 amperes of current is flowing. 3 amperes enters the lamp, then 2 amperes enters the resistor. You can see 3 amperes with these 2 amperes will give us these 5 amperes. You can see the 5 amperes because of what the addition of these 2. 3 amperes added to 2 amperes. At this point, 2 of them are added, so that's why we have 5 amperes going on. Now, what are the advantages of connecting 2 lamps in parallel rather than in series to a power supply? When connected in parallel, 1. The lamps are brighter than when connected in series. 2. The lamps can be controlled individually with switches. 3. One lamp will continue working even the other does not. Let us look at this question. Calculate the currents measured by ammeters A1, A2 and A3 in the circuit below. Here we have the ammeters A1, A2 and A3. So now the A1, A2, A3. A1 will give us 2 amperes. A2 will give us 4 amperes. And A3 will give us 6 amperes. Now choose appropriate words to fill the gaps below. Now, here are the options. So, here we have the option. So I'm waiting for you. Now, when components are connected together in series, they will all have the same current flowing through each of them. When components are connected in parallel to each other, they will each have the same voltage. Lamps are usually connected in parallel to each other, as this allows them to be controlled individually by switches. And if one lamp blows, the others can still continue to operate. Summary. An electrical conductor is a material through which electric current flows easily. All metals are conductors. Electrical insulators have a very high resistance to the flow of current. Ohm's law states, at constant temperature and other physical factors, the potential difference across N is directly proportional to the current passing through a conductor, that is the wire. Potential difference PD between any 2 points in a circuit is the work done when one coulomb of charge moves from one end of the circuit to the other, that is the positive to the negative pole. The EMF, that is the electromotive force of the cell in volts, is the potential difference between the terminals of the cell when it is not delivering any current to the circuit. The instrument for measuring PD is known as a voltmeter. Thanks for watching.
There is no